Hello, my name is Grant Powell. This will be the third how-to video on the Digilab 1 kit. In the last how-to video, there was an introduction to the hardware with a basic example of an AND gate circuit. In this example, we will be using a 2-bit adder. So in the circuit I have designed here, I'll show it now on the camera. It simply uses one XOR IC, one double input AND chip IC, and then a double input OR gate IC. This is used to achieve a 2-bit adder in the circuit design. Just a quick overview of the way I have the inputs and outputs set up. I have my first 2-bit number set up to switches 6 and 7, with the low bit being on 7, and then for the second 2-bit number I have those wired into switches 4 and 5, with the low bit being 5. And then for our output LEDs, I have the 3-bit output to switch to LEDs 5, 6, and 7, with the low bit being 7, and then we just have 5-volt and ground going to the rails on the breadboard, powering all of the ICs. So getting into it, the software and its capabilities, there are 4 different features that you are able to use when testing circuits. That is the lab creation, custom test, lab testing, and state machine. So the workflow that these entail is custom test allows you to define truth tables and see the results without testing them against an answer key. So this allows students to, we'll make a simple test. We'll do 4 rows of default binary. This is going to be adding our numbers together, and then I will edit it a little bit to make it to where we are now adding our first 2-bit number, switches 4 and 5, to our second 2-bit number, 6 and 7, and measuring the results on switches 5, 6, and 7. On LEDs 5, 6, and 7. So we can just do a quick test to see what our expected output would be. So it looks like we had a 0 plus 0 is 0, a 0 plus 1 is a 1, a 2 plus a 2 is a 4, and then a 2 plus a 3 is a 5, as you can see right here. So this is custom test. It just allows for you to debug your circuit with different custom truth tables to see what's going on. Maybe you need to test an AND gate circuit and you need to know if the AND chip is good, so you could define a truth table of something along the lines of 3 rows. At any time you can use the question marks to see the documentation on specific tools. So you can see here the custom test documentation. It links you straight to it. So that's just the overview on custom test. It's just an extra tool to allow students to use. Into the meat and potatoes, the lab creation. So this is where instructors or students, if they wanted to, could create lab files to test inputs against expected outputs. So what this does is it uses the inputs you define, sends them to the Digilab, does the inputs, and then sends the outputs back to the program here and measures those outputs to the expected outputs you type in here. So to save the hassle, I have pre-made a file for the 2-bit adder as an editable Digilab file. That is very important. So any editable file you make requires a password. As you can see, my password 123 is very secure, and I just loaded it in. And this is my 2-bit adder truth table. It tests all the possible permutations of the 2-bit adder, just 16 rows of truth table, and then the expected results of a truth table. So this is the first 2-bit number added to the second 2-bit number and its results displayed on LEDs 5, 6, and 7. So this editable is very important. It is toggleable, so you can make a lab editable, save it, call it 2-bit adder. So now we have a 2-bit adder file that is non-editable. This would be the file distributed to the students. The reason being is that you cannot load non-editables. And just to showcase that, since I already had it filed, we can load the non-editable file. Students cannot access that resource. But the editable file an instructor would keep while they're iterating through their truth table design. All you need is your password, and you are able to edit your truth table while you are getting it ready to distribute to the students. So that's just an overview on the lab creation. All editable tables do get the tools icon here, which allows you to do different operations on said file to be able to make your truth tables. If you have any feedback on what you would like added to the tools, we have a feedback form here that you can fill out and send to us to let us know what you would like to see. But that is an overview of lab creation. Oh, one last note. There is don't care supported in this system. So if your truth table, you're doing a JK flip-flop, you're doing some sort of state machine, and you need to have don't cares in your truth table definition, you are able to do this by just simply clicking the ones into X's before it cycles back to zeros. But that is lab creation. So you've made a lab, you've downloaded the .digilab lab you have created, you upload it to Canvas, and you distribute it to the students. Students would be using it in the lab testing section here. So again, anytime you can see the documentation on this, but very simple. You load your Digilab file. So once you load the lab file, you get to see the switch inputs defined here on the left, your measured outputs, and then your results. And this is comparing the measured outputs to your expected outputs you defined in the lab creation. So you get a couple tools. Mainly you load the lab, which we just did. You can reset. It does not clear the loaded lab. It clears the outputs in case you do multiple iterations. And then your auto test and run one row. So we could run the first row, the second row, the third row, see what the state of our circuit is doing. We can reset this back, and then we can decide to run the entire lab test. So now we can see it running our 2-bit adder truth table that we have defined, and it looks like the 2-bit adder circuit we have created successfully operates as a 2-bit adder with all the possible combinations. So this is a good example to show you how much faster the testing scale of your circuit can be. So say you had a 4-bit adder, you would be needing 3 times the amount of rows in this, and that would take you 3 times the amount of time to cycle through the switches and do that. So a couple notes about this. Anytime you get a fail, it'll showcase that on the truth table. So let's go ahead and load that editable adder file we made. Input our password. So let's go ahead and let's just invert the expected outputs. This is going to completely make the test fail, but I would just like to showcase what that looks like. So let's save the lab file again, and we'll do 2-bit adder fail, and then back to our lab testing, and then we will be loading the lab and testing the lab, and then running said lab test. So you're going to see that it failed absolutely every operation. Even though we are getting the expected results of a 2-bit adder, we do not pass those since we defined our file as inverted output. So it's just very important to know that whatever you put into the lab file is what it's testing for. That goes for what switches are connected to what LEDs are connected to what, and what your expected results would be. So that's just a brief overview of how to use the software suite for the circuits testing. The last test is state machine testing, and this will be overviewed in a separate how-to video. Thank you for your time, and any questions can be put in feedback.